welcome back to Introduction to Physics Labs. My name is Paul Eric, and today we're going to be doing Lab 3.4a, which is on interference and diffraction. So if you've been watching my other video labs, the previous one we talked about what reflection and refraction were. And so now we're going to add what is interference and what is diffraction. So our purpose is to be able to define what a wave's amplitude, wavelength, frequency, and speed are. Then we're going to add waves together constructively and destructively. Then we're going to do double slit interference with water waves, sound waves, and light. And we're going to predict how does the wave change depending on the wavelength and the size of the slits, or the slit separation. And then we're going to do single slit diffraction with water waves and predict again how does the wave change as you change the wavelength and the size of the slit. Okay, so now we're going to go to the lab, and it says to open PhET wave interference. So we're going to go to the internet and we're going to find this simulation. Okay, then we're going to click on waves, and we've got this. Okay, now if we click on this green dot here, it's going to start to drip, and then each drop is going to be creating these circular patterns. But we need to know what's the significance of the circles. So we're going to go ahead and stop this again, and we're going to do a side view. So over here you've got the top view, and if you click on this, then it flips it over to the side view. Okay, and again we're going to be turning on the faucet there, and you can see that it is making waves. So let's go back to the lab here for a second. So we've clicked on the side view, we've pressed the green button, and then it says to change the amplitude slider and observe how the wave changes. So if we go back to here, we can change the frequency of the wave, and we can also change the amplitude of the wave with the slider here. And so I'm not going to do it for you, but I want you to do it. So if we go back to the lab, it says to change the amplitude, and then note what is it about the wave that's going to change when you do that. And then fill in this thing here. For a water wave, the amplitude is the what of the wave. Okay, now it says to go back and to click on the top view. Now you might need to toggle back and forth in order to get this right, but we're going to go from this view here to this view here, and your goal is to figure out, let me go ahead and pause this so you can stop the animation like that. And that's really the best thing to do, is to pause it so that these things aren't moving. And you notice that it's bright and then it's dark. And I want you to figure out what part of the wave corresponds to the bright part and what corresponds to the dark part. And remember that you can take this picture and you can flip it sideways, so that you can compare this to the previous picture and figure out what does the blue part represent and then what does the black part represent. Okay, then once you've done that, then each blue ring, is it going to be a crest or is it going to be a trough? And then each black ring, is it going to be a crest or is it going to be a trough? Okay, now you're going to turn on the simulation again, so it's moving, and you're going to move the frequency slider and observe how the wave changes. Then define what frequency is. So you might need to look that up in your notes, or you might need to go to the internet, but find out exactly what do I mean by the frequency of a wave. Now move the frequency slider back to the middle, and then you're going to drag out the stopwatch. So if we go back to the simulation here, you can get a stopwatch. Now I would take the stopwatch and I'd put it over here somewhere, maybe right next to the button, so that once you get this thing going, you've got access to your stopwatch. But you can put it anywhere that you want. So you're going to drag out the stopwatch and you're going to calculate the frequency of the water drops using the following equation. Number of drops that fall, and then the total time it takes it to do it in. So if you want to let 10 water drops fall, then your equation is going to be 10 and then divided by the time it took for those 10 water droplets to fall. Does that sound familiar? It should, because we did a lab like with the pendulum, and we said that the frequency of a pendulum was we let it swing back and forth 10 times, and we had our stopwatch and we measured how long does it take it to do that in. And then we used the equation very similar to this. The only difference was it was the number of swings up here and then the total time it takes. Now, also, I want you to calculate the period. So the period is going to be the time it's going to take for one drop to fall. Now, the problem, though, is that's very difficult to do because of your reflexes. You'd have to turn on your stopwatch and then almost immediately turn off your stopwatch in order to be able to do that. So there's another way of doing it. And so that's by using this formula right here. So this T thing, that's the period. So the period, which is the time it's going to take for one droplet to fall, is going to be equal to 1 divided by the frequency. And so you're going to get your frequency from up here, and then just plug it in there, and now you've got the period. Now it says to record this in the table below. So we got a big table down here. Now you get to choose how many drops that are going to fall. Total time it's going to take for the drops to fall in seconds, your calculated frequency, and then your calculated period. So you're going to get all of that information and then record it. Okay, now we've got the wavelength of the wave. So you might need to go to your notes, or you might need to go to the internet and find out what do we mean by the wavelength of a wave. And so you're going to fill in this blank right here. Okay, now you're going to go back to the simulation, and it says to get out the yellow and blue tape measure. So if we go back to here, we can get out a tape measure. Now this one might be easy. You can either do it with the rings, or you can do it with this. So it's up to you however you want to measure the wavelength. But if you take this and you put it there, and then let's say, notice I can grab this and I can pull it out. And so if I pull this out, that's going to measure the distance from here to here in centimeters. Now the problem, though, is that's the wrong unit. So the correct metric unit is going to be the meter. And so you're going to be measuring the wavelength of your wave. And so it says to get out the tape measure, measure the wavelength, record it below, down here. Okay, now once you've got those two things, now you can figure out the speed of the wave. Now be very careful, because unfortunately a V for velocity looks very similar to this one, which I call nu, and that is the Greek letter N, and it stands for frequency. So this V up here, this is for velocity or speed, and then this is the one for frequency. And if you look here, this is the V, And then this one over here, that's the Greek letter nu. So be careful, and you're going to calculate the speed of your wave. And then record it down here. And then you're going to calculate the speed a second way. So speed is distance divided by time. So think about miles per hour or kilometers per hour. It's a distance divided by time. So all you have to do is turn on the animation, look at one wave as it's traveling, time how long does it take that wave to go all the way across the simulation, and then measure with your measuring tape the distance it travels all the way across, and then you can calculate the speed. So R is the distance, T is the time, and you can calculate the speed of the wave. And so now you're going to have two different speeds, which should, what do you think? How do you think they should relate to each other? So you've got this speed here calculated using the wavelength and the frequency, and then you got this speed here calculated using distance and time, and you should notice that they're pretty much the same numbers. All right, so here you're going to fill in this table. Okay, then it says to increase the frequency of your wave, and then look at what happens to the wavelength. And so does the wavelength increase or does the wavelength decrease if you do that? So remember, what's the definition of the wavelength? And then also remember that the wavelength multiplied by the frequency is the speed of the water waves. Well, that's not changing. So the speed is the same, and so the question is that if you increase this, so if you make this bigger, what does this have to do over here in order to compensate? And so again, remember that 4 is equal to 4 times 1. But it's also equal to 1 times 4. So you notice that if one of the numbers gets bigger, the other number gets smaller in order to compensate. And I think I just gave it away, but there you go. All right, now we're going to be ready for part 2 of the lab, and so I will be back in just one moment.